Welcome back to my channel. Today I am going to discuss about some problems on a solution chapter. So first I have listed here the number of formulas in a solution. Okay, these are first we have to list out all the formulas. The first one is molarity. We know that a molarity is number of moles of solute dissolved in a 1 liter of solution. So here WB into 1000 divided by MB into V. Here WB stands for mass of the solute, MB a molar mass of solute, V is a volume of solution. Here the unit will be moles per liter. Okay, the second one is molality. The number of moles of solute dissolved in a 1 kg of solvent. Okay, so WB into 1000 divided by MB into WA. Here we know that already WB is mass of solute, MB is the molar mass of a solute. Here WA is a weight of solvent. So next, mole fraction of the solute. Here XB is equal to NB divided by Na plus NB, and mole fraction of a solvent, that is XA is equal to Na divided by Na plus NB. Here always we have to remember B stands for a solute, A stands for a solvent. It may be Ma, MB or WA, WB. Here NB is number of moles of solute, Na is number of moles of solvent. Here it is the mole fraction for a solute and mole fraction of solvent. Okay, the next formula is Henry's law. Here we know that Henry's law is the vapor pressure is directly proportional to the mole fraction of the gas. Here the KH is what? Henry's law constant. P is the partial pressure, X is a mole fraction of the gas, KH is the Henry's law constant. Similarly, Raoult's law. Here the Raoult's law, total vapor pressure is equal to P is equal to 2 partial pressure P1 plus P2. So P is equal to P0 1 x1 plus P0 2 x2. And the next formula is relative lowering of vapor pressure. Here MB is equal to WB into MA into P0A divided by WA into P0A minus PA. Here already we know that WA is weight of solvent, WB is weight of solute, and Ma is molecular mass of a solvent and MB is the solute. So here the relative lowering of vapor pressure means when you are adding a solute to the solvent, there is a lowering of a vapor pressure in solvent in the solution. So that here we are taking the difference between the partial vapor pressure of a solvent and the vapor pressure of a solvent. Okay, the next one is elevation of boiling point. Here the thing is same. When we add a solute to the solvent, so it becomes a solution. So here we are taking a two difference, that is two temperature differences of solvent and the solution. So here elevation means increasing of boiling point when we are adding solute to the solvent, means the difference between the temperature of solvent and the solution is called elevation of boiling point. Here delta TB is equal to KB into WB into 1000 divided by MB into WA. Here already we know that WB, MB and WA. Here delta TB is elevation in boiling point and KB is ebullioscopy constant. Okay, the last formula, depression of freezing point. Here, when we add solute to the solvent, so there is decrease in the temperature. Okay, that is called a depression of freezing point. Here, the difference between the temperature of solvent and the solution, okay, that is called a depression of freezing point. Here, delta Tf is equal to Kf into Wb into 1000 divided by Mb into Wa. Here Mb means if they ask for calculating a molecular mass of a solute, so we can interchange here Kf into Wb into 1000 divided by delta Tf into Wa. So here we know that delta Tf is depression of freezing point and Kf is cryoscopy constant. So on basis of these formulae, now we shall solve some problems. Okay, the first one is 450 cm cube of an aqueous solution of a protein container 1 gram of the protein. The osmotic pressure of such a solution at 310 Kelvin is found to be 3.1 into 10 raised to minus 4 bar. Calculate the molar mass of a protein. Here R is given. Okay, this problem is asked in March 2023. So here first we have to write what are the given things. So once again read the question. 450 cm cube of an aqueous solution. So here cm cube, okay, that is volume. V is equal to 450 cm cube. So we have to convert it into liter. So it becomes 450, sorry, 0.450 liter. Okay, so then they have given Wb, that is, sorry, W. You can take here because there is no solvent they have given. So we have to take just W. W is 1 gram. Okay, next, the osmotic pressure of such a solution at 310 Kelvin is found to be 3.1 into 10 raised to minus 4 bar. Here the osmotic pressure value pi is equal to 3.1 into 10 raised to minus 4 bar. Then temperature is given 310 Kelvin. Okay, now write the formula. M2 is equal to W2 into R into T divided by pi into V. Okay, let us substitute all the given things. So we know that the weight, that is W1 into R is given 0.083 into 310 divided by, we know the pi value 3.1 into 10 raised to minus 4 into the volume is 0.450. So you can use the calculator and try this one. I will give a direct answer, that is 184444 grams per mole. Okay, this is answer. So you can check with the help of a calculator. Okay, the now next move to the next problem. 1 gram of a non-electrolyte solute dissolved in a 50 gram of a benzene lowered the freezing point of a benzene by 0.40 Kelvin. The freezing point depression constant of a benzene is 5.12 Kelvin kg per mole. Find the molar mass of a solute. Okay, this question is asked in May 2023. So first we have to write all the given things. Okay. So here 1 gram of non-electrolyte solute, always we know that here, so we can write the solute as WA. They have given WA is equal to, WB is equal to 1 gram. Then WA, yes, here WA is the solute dissolved in 50 gram of a benzene, that is lower the freezing point of a benzene. Okay, here 50 gram. Okay, now on dissolving 3.46 gram of a non-volatile solute in 100 gram of water, the boiling point of the solution was rise to that of pure water by 0.12 Kelvin. Calculate the molar mass of non-volatile solute. So here yes, on dissolving 3.46 gram of a non-volatile solute in 100 gram of water. Here the WA is what? WB is 3.46 gram. Then WA is 100 gram. Then the boiling point of a solution was right to that of pure water by 0.12 Kelvin. So here delta TB, okay, delta TB is 0.12 Kelvin. So here the KB is given. Now write the formula. MB is equal to KB into WB into 1000 divided by delta TB into WA. Okay, here we have to find out the molar mass of a non-volatile solute. Okay, all these are given things. So put all the values. The KB value is 0.51 into WB 3.46 into 1000. The delta TB value 0.12 into WA is 100. Okay, after calculating we'll get the value 147.05 grams per mole. Okay, the last problem. The vapor pressure of a benzene is 200 mm of Hg when 2 gram of a non-volatile solute dissolved in a 78 gram benzene. Benzene has a vapor pressure of 195 mm of Hg. Calculate the molar mass of the solute. Okay, here the problem is based on a relative lowering of a vapor pressure. So already we know that the formula. So on that basis we have to calculate the given things. First, the first thing we have to do is what are the given things. We have to write what are the given things here. Okay, the vapor pressure of benzene is 200 mm of Hg, and when 2 grams of a non-volatile solid, here 2 grams, that is WB is 2 gram, the WA is 78 gram benzene. Okay, 78 gram benzene of the vapor has the vapor pressure of 195 mm of Hg. Calculate the molar mass of a solute. So here they have given two vapor pressure for a solute and for a solvent. So here P naught A is equal to 200 and PA is equal to 195. Okay, so write the formula. MB is equal to WB into MA into P naught A divided by WA into P naught A minus PA. Okay, substitute all the values here. WB is 2 into MA. So the MA is also given here. $78 into 200 divided by WA is, this is also 78 because the molar mass of a benzene is 78 and they have given the solvent 78 gram of benzene. Okay, into 200 minus 195. Okay, after calculating you will get 80 grams per mole. So here always they have they have given all the contents, like here we have to calculate only MB. All these are given things. So first we have to understand the terms in a formula. That is, if we don't know the WB, ME or P naught way, we cannot list out the given things. So first thing is we have to understand the formula and what are the terms. Again I will tell you once again, the B always stands for solute and A indicates the solvent. Okay, if you understand these two, you can easily remember all the formulas. Hope you understand the problems based on a solution. If you want any concept, you can comment in a comment box, and please subscribe my channel. Thank you.